Talk about the different terms for concentration and the different concentrations themselves. Start with a couple terms. So of course dilute means a lower concentration. And concentrated is a higher concentration. And this time I'm going to use CONC as my abbreviation for concentration. And I just want to make sure we know how to use these terms. So A, 0.010 molar HCl is a dilute solution of a strong acid. While 12 molar acetic acid is a concentrated solution of a weak acid. So if I were to describe my coffee, which I wish I had right now, I would call it a concentrated solution. That would be a better chemistry term than a strong solution. Now we've worked with molarity before, but let's go ahead and work one problem with molarity before we get to the next page and the next set of units. Of course, molarity is moles of solute over liters of solution. In this problem, we've got 17.2 grams of sodium chloride that has been placed into 0.500 kilograms of H2O to make 491 milliliters of solution. And perhaps the first thing you notice is we have kilogram data here, which we don't usually have. We will use that in the next. Maybe the second thing you notice is that there are more, so this is, well, if we were to use grams, this would be 500 grams. And 500 grams, well, the density of a sodium chloride solution is greater than 1, so grams divided by milliliters will be a number slightly larger than 1. To do this, of course, we take our 17.2 grams of sodium chloride, convert it into moles, then we'll have our moles, we'll convert our milliliters into liters. Got my calculator right here from my periodic table, which I know is around here somewhere. I know that, no, I probably know them anyway, but just in, voila, 22.99 sodium, 35.45 for chloride, $58.44. Grams of sodium chloride per 1 mole. I get 0.294 moles. My liters of solution 0.491 liters. Divide those two numbers. .599. Capital M for molarity, sodium chloride. Done this before, hopefully this seems pretty familiar. Watch as I do chemistry magic. I'm going to turn that R into an L, believe it or not. Our other unit is molality, and not only did I turn that R into an L, but I also turned that capital M for molarity into a lowercase m for molality. It is defined as moles of solute over kilograms of solvent, and it's defined in terms of amount of solvent, not solution. And because we're weighing the solvent and more than likely weighing the solute as well, which we did in this problem here, we're using masses, and masses, the amount does not vary with temperature, and that oftentimes will help us simplify some things. So now we're going to calculate the molality of the same solution we talked about on the last page. It's going to be the same number of moles. So we're still going to use our 0.294, but we're going to put it over 0.500 kilograms of solvent. And when we do that, we get a slightly different number. 0.294 divided by 0.5, 0.588. This is lowercase m for molality, sodium chloride. Those are units of molality. You will have on your conversion and equation sheets definitions of each of these just to make sure you can keep them separated. While we're here, let's revisit percent composition by mass. There we go. And do the same problem where this time it's going to be mass of solution on the bottom, which is the solute plus the solvent. So, and it's all masses. So mass of solute, 17.2 grams over solute plus solvent. So 17.2 grams. This is going to be 500 grams. And we get 517.2 grams of solution. Times 100%. Let's go ahead and work this out. .33% sodium chloride mass by mass. And those are really the most common concentration units you should expect to see in chemistry classes and in life. Now, parts per million, again, let's talk about all the different units here. These are used for very dilute solutions. We've given the definition of this before. It's 1 part per million of solute equals 1 gram of solute over 1 milliliter of solution times 10 to the minus 6. So, right, this is our unit conversion factor that we use. So it's really, you can put this 10 to the 6 up top. Like so. And either way, you can use these as unit conversion factors. Now, I'm going to do one other thing here. So instead of doing this, you can, in another way, do 1 times 10 to the minus 3 grams of solute over 1 times 10 to the 3 milliliters of solution. And in fact, our last stop on the part per million scale is going to be this 1 times 10 to the minus 3 grams is milligrams, and 1 times 10 to the 3 milliliters is liters. And oftentimes, and this is happening more and more, you'll see something listed as milligrams of solute over liters of solution, or yeah, that's actually weight per volume or mass per volume, how you typically see it more and more these days.